Hello everyone and welcome back to another video provided by SVSU's online tutoring. My name is Joel and today we will begin with Chapter 8, which is Quadratic Functions, Equations, and Inequalities. And the first section that we'll start with is 8.1, and that's solving quadratic equations, factoring, and special forms. So this section will introduce solving quadratic equations, and we'll get solutions that are both real and complex. So that's what I assume by what they mean with the special forms right here. Yeah, the special forms right there. But this video will just focus on solving quadratic equations by factoring. Okay. And if you're a little rusty, you can go back to Chapter 5 and Section 5.6 for some review practice. So if we have this quadratic equation, x squared plus x equaling 6, what we have to do to solve this is get it into standard form. And the standard form for a quadratic equation is ax squared plus bx plus c equaling 0, where a and b are just leading coefficients. So in this case, they're both 1. But remember, we don't have to write the 1, so we just omit from writing those. So what we have to do is that we have to just subtract 6 on both sides, and we'll get x squared plus 6 minus, x squared plus x minus 6 equaling 0. And so to factor this, what we want to think of for our first spot right there is a number or variable that when multiplied together will give us x squared, and so that's obviously x. Okay, and then the second thing is that we want to figure out is what other numbers will be going here and what their sign is. Okay, so are they positive or negative? So let me fix that. Are they? And all this notation means is that the plus sign is considered before the minus sign, and over here the minus sign is considered before the plus sign, because we don't know what the signs of these numbers are. But what we can do is that we can look at the factor tree for -6, right? So what values will give us -6? So we have plus or minus 6 and minus plus 1. Okay. But the thing is that if we were to add these together, we wouldn't get a 1x. So instead, we have to think about smaller numbers that are on the factor tree for 6. Okay, and the ones that we want to look at are, if we just have positive 6 here, are 2 and 3, right? So if I get rid of this part here and this part here, we know that our b term is positive, right? So what that tells us is that the 3 must also be positive because that's larger than 2. So the 2 will be negative. So that way, and to check this, we can just FOIL, right? So we have x times x, which gives us x squared, and we have -2 times x, which gives us -2x. And then we can do x times 3, which gives us 3x, and then -2 times +3, which gives us -6. And then we add like terms, and we end up with x squared plus x minus 6. That's what the rate, plus 6 minus 6 equaling 0. So we end up with the same quadratic equation that we had in the beginning, so we know that we're right. Okay, let me make some room here. So the second example is if we have 3x squared plus 7x minus 6 equaling 0. And so the first thing that we want to think about are what factors go here that will give us 3x squared. And since 3 is a prime number, its factor tree only has 3 and 1. So we know that we should have a 3x here and then an x right here. Okay, and so for here, this is a little bit trickier because while we want to think about the factors for -6, we want to be sure that we're able to get this positive 7x, which is a kind of a high number for this quadratic equation. So the placement of our factors for 6 have to be considered carefully. So we know that our b term is positive, right? So, and not only that, but it's also fairly large. So just taking a guess, we can try positive 3 here. So that way it's going to be multiplied by this 3x, and then we can put -2 here. And the reason for that is when we multiply 2 and 3, we want to get a -6, so the 2 has to be negative. So if we go and check that, we can just FOIL again, right? So we have 3x squared plus 9x, and we move on to -2. So we have -2, and then -6, and then combine like terms, we have -x squared plus 7x minus 6 equaling 0. So again, we're good there. Real quick, what I want to do is that the whole point of solving quadratic equations is that we want to get solutions, right? So go back to this guy real quick, and we'll go down here, and we want to find what the x values are for that quadratic equation. So since we're multiplying these our two factors together, we can just set each of them equal to 0 individually. So we have x minus 2 equal to 0, and we have x plus 3 equal to 0. And once you solve for x, you should see that x equals 2 and x equals -3. So for this quadratic equation, these two x values would be our solutions. And likewise, we want to find the solutions for this quadratic equation. So we look at our factorization right there, and I'll go down here. And so we set each of those equal to 0. So we have 3x minus 2 equaling 0, and we have x plus 3 equaling 0. And you'll see that if you solve for x, for the first one you'll get x is equal to 2/3, and then for the second one you'll get x is equal to -3. So those two x values would be our solutions for the quadratic equation. And finally, if we have 7x squared plus x plus 16 equaling 6x squared plus 9x, how do we go about solving this? Well, again, we want our quadratic equation to be in standard form. So what I can do is that I can subtract the 6x squared and the 9x from both sides. So we have the 7x squared will be reduced by the 6x squared. So we'll have just x squared, and then it'll be x minus 9x, which gives us -8x. And then the positive 16 is just left alone. So then, now this is in standard form, it also equals 0, right? So now we can go about factoring and solving for this quadratic equation to get solutions. So again, x times x will give us x squared. So our first term is satisfied. And then we have to think of the factor tree for 16, that when the two numbers multiply together will give us 16, but when added will give us -8. So since our c term is positive, but our b term is negative, that suggests that both numbers are negative, and they're actually the same number, which is -4. So we can rewrite this as to get solutions, we can rewrite this as x minus 4 equals 0, and then x minus 4 equals 0. And so when you solve them, they'll actually have the same solution, which is x equal to 4. So if you were to graph that, if I go down here, make some more room, if you were to graph that, you would have something like this. We have our y-axis here, our x-axis, x and y. So way out here we have x equals to 4, and so right there is where it equals 0. So we have our quadratic equation. Let's see, what would the y-intercept be? If x is 0, then we have 16. So way up here is 16. So we have something that looks like that. And so that's what the graph would look like for this quadratic equation, if you were just curious. So that'll do it for this topic. In the next one we will look at the square root property for solving quadratic equations. Alright, see you next time.